And instead of just naming them by their angles and their sides, like a scalene right triangle, for example, we looked at them in a new way and we talked about a triangle being a regular or an irregular triangle. And now we're going to look at quadrilaterals and can make that same determination. So I start with the geometry sticks, and I've made here a quadrilateral. It has four, hold it in front of the white, you can probably see the colors a little bit better there. So you can see that the sides are all different lengths. The angles are all different. We've got four different angles here. So I'm going to set it down, and I'm going to mark it as non-equilateral, meaning that the sides are not equal. And what about the angles? It is non-equilateral and it is non-equiangular. Okay, so the angles and the sides don't match, are non-equilateral and non-equiangular. All right, so let's take a look then. We're going to do a rectangle. So my rectangle has two sets of parallel sides. A rectangle, by definition, has four right angles. It does not have four right angles. It is not a rectangle. So, of course, these move because they're geometry sticks, but I'm trying to hold it steady. This is a rectangle with four right angles. As I set that down, adjust it with my measuring angle, I can say that it is non-equilateral because the sides are different. But it is equiangular. All four angles are right angles. They are each 90 degrees. So it is non-equiangular, but it is non-equilateral, but it is equiangular. All right, let's then take a look at a rhombus. So a rhombus, again, by definition, let me put it here so you can see, has four equal sides. All the sides are the same length. But a rhombus has obtuse angles and acute angles. It is, if I'm holding it correctly, it is equilateral, but it is non-equiangular. And then finally, in the fourth that I'm making right now, I have my square. A square, of course, has four equal sides, and a square has four right angles. So my square is equilateral, and a square is equiangular. So of these, if a shape has two positive qualities, we call that a regular. If it has either two negative qualities or a negative and a positive, that's an irregular. So our quadrilateral, common quadrilateral, is non-equiangular and non-equilateral. So that is an irregular shape, irregular. Our rectangle, equiangular, yes, but non-equilateral, is an irregular shape. Our rhombus, equilateral, but non-equiangular, also an irregular shape. Our square is equiangular. Our square is equilateral. It is a regular shape. Now, I'm going to write up on the board so that you can see it a little more easily. Irregular. Regular. rather than try to draw the shapes or trace the shapes onto the whiteboard, which could damage the materials, I'm going to write their names. But we're going to take a look at all of our quadrilaterals. I am using actually the tray from the primary class today for our equilaterals. So I'm not going to do a common, well, I'll just write it. Common quadrilateral. A common quadrilateral is irregular. Okay, so let's take a look. Let's take a look. Here is our parallelogram. Parallelogram, let's see. Is it equilateral? No. Equiangular? No. So parallelogram is irregular. Okay. Our rhombus. Is it equilateral? Yes. Is it equiangular? No. So a rhombus is irregular. Our trapezoid. I'm going to go with just this trapezoid. Is it equilateral? Definitely not. Is it equiangular? No, it is not. So our trapezoid, all the trapezoids are irregular. I'm not going to go through each kind of trapezoid right now. Any trapezoid would be considered irregular. Now let's look at our kite. Kite is a quadrilateral. A kite, is it equilateral? No. Is it equiangular? No, it is not. So a kite is also irregular. And then we were talking about rectangles. What about our rectangle? It is equiangular, but it is not equilateral. So a rectangle is also irregular. What do we have left? Our square. Our square. Again, remember the king or the queen of the quadrilaterals. Because what can a square do that no other quadrilateral can do? The square can fit in its frame in any direction. I showed you this years ago, but it's relevant to what we're doing now. And that's one of the reasons that we made a big deal about it then, because a square is a quadrilateral. A square is a rectangle. But what makes it really catch our eye, just like the equilateral triangle, is that it is the only regular quadrilateral. So that makes it sort of special. That makes it notable and important to us. So our square is a regular. I'm going to put it right up here because it is the king or queen. The square is regular. It is equiangular and equilateral. So like last time, what I would like you to do is in your math notebook on your grid paper, I want you to put irregular quadrilaterals and regular quadrilateral. And then draw, please, with a ruler. Just two examples of irregular, and then the only example that exists of the regular quadrilateral. You do need to write down the names of them. So, you know, if when you want to do one and you don't know the name, look it up. Make sure you spell it correctly because it does matter. Take the time to do it correctly. Use a ruler so that your lines are straight. With the square or the rectangle, I would ask that you use the corners that are right there in your grid. There's no reason that you shouldn't have nice, neat, right angles there. All right, that is it. Thank you very much.